Welcome to the lesson Area Between Curves, which is the first lesson in chapter 6, that is the applications of the definite integrals. Before we begin with the lesson, let's go through the learning objectives for this lesson. It is to find the area between two curves using definite integration and compute the area of a region using definite integration with y as a variable. We generally denote x as the variable, we solve x as the variable, but if we are taking the horizontal axis in consideration, then y will be the variable. We will learn about these in the coming videos. And the keywords in this lesson is area between curves. This is the upper function, this is the lower function. You need to find the area between them. So before we start with the problems, let's quickly see what it means, area between curves. You have been given two functions, y is equal to f of x and y is equal to g of x. Now the function can be, say now for example, the figure is over here. It can be anything. It's not definite object. If you have a definite object, we can easily find the area. If it's a square or a triangle or a rhombus, we can find using formulas. But over here, it's just a curve. But we know the function of the curve, and over here, there's another curve. We need the area between these two. So this is the upper function. If we integrate, definite integrate means between the limits, this function between the limits, and subtract, so it will be entire region, isn't it? And subtract whatever is this. So basically now imagine you have this block, I'll shade this region. So you know the area of this region, you know the total area. How would you find the remaining area? So the total, say it's 100, the total, and the shaded is 50. How would you find this one? Then just subtract 100 minus 50. So 50 would be a simple one. So I'll just take it as 60. Okay. So just for differentiation's sake, 60 is over here, the shaded. Total is 100. How much is this? 100 minus 60 will give you 40. Similar to it. It's not exactly the same thing because over here it's entirely different, the curves and everything. But I'm just trying to make you understand. When you find the definite integral of this function, you get the entire area in this region. But you subtract the lower function, you will get the remaining area, whatever is required. So the formula is very, very simple. Integral a to b, upper function minus the lower function. So this will be the formula. Please stay tuned for the coming videos. We will start solving problems using this formula.